Hello, Akshat. How are you doing?
I'm good, sir. How are you?
Very good, very good. So, how was your first day at school and what did you learn in advanced functions today?
It was really good, sir. Today we basically touched upon the basics of what a function is, and merely was just a review of grade 11 functions.
Okay,
So that was just a quick wrap up.
very good. So, what will you like to learn today?
Sir, today I think I would want to learn a question from page number 12 on my advanced functions textbook.
Why
And
don't you
I wish
share it?
to, yes, sir.
Share
And I
it.
also wish to review the characteristics of parent
Okay,
functions. So
okay, sure.
yeah,
Sure,
I'll just share the book.
sure.
You can see, sir?
Yeah, yeah, I can. Yes.
Okay, perfect. I'll just pull up the question. This one, sir.
Can you please read the question?
Yes, sir. Martin wants to build an additional closet in a corner of his bedroom. Because the closet will be in a corner, only two new walls need to be built. The total length of the two new walls must be 12 meters. Martin wants the length of the closet to be twice as long as the width, as shown in the diagram. Explain why L equals to 2W. I understand that, sir. L equals to
Yeah,
2W because Martin
correct.
wants it to be. Yeah.
Yes. So,
And
that's
then
okay.
let the,
Hmm.
yeah, let the function f of L be the sum of the length and the width. Find the equation for f of L. So this is primarily what I needed, a little bit of confirmation.
Okay. So, what do you say it should be? Like f of L, they are saying directly is sum of length and width, right?
Length and width, yeah.
Length plus width. Now, important thing here to understand is that f of L, that means L is your independent variable. You get the idea.
Right, yes.
So you have an equation that L equals to 2 times W. That means you have to write what W is. So
Yeah.
L over 2 is W, correct? So replace
Okay,
this
so
width as L plus L over 2. Do you see that?
so
And
3
what do
over
you get?
2L, right?
3 over 2L. Is that okay? 1.5.
Oh,
So
okay,
that
okay.
becomes the function f of L. Is that clear to you?
Yes, sir. I did that too, but I just didn't know if I did it correctly. So
Correct.
now I know for sure. Yeah.
So now you have to graph f of L. So 3 by 2L is like a direct variation, right?
Rise over run, right? So rise by
Yeah,
2
it's
and the
just
right.
the, yeah. So it is a straight line which goes through the center, correct?
Yes.
But a slope of 1.5, correct? So you can
Yeah.
say, yeah, any particular point here, if it is 1 here, then this will be 1.5. Is that clear to you?
Yes, sir.
So that gives you a slope of 3 over 2, where independent variable is L and the dependent variable is
Period.
f of L. Is that clear to you?
Yeah. Yes, sir.
So that is how you're going to do this particular question.
Sir, and
Does
when it
it
says
continue?
find the desired length and width,
Correct. What are
uh,
you given?
you just give 12 and you solve for L and W, right?
Yeah. So you've got one equation. So you have 12 is the perimeter, right? So I mean, total length of the two new walls is
Yeah.
will be 12. That means 12 is equals to 3 by 2 of L, correct?
Yeah.
So you can find L as 24 over 3, which is 8, right?
So 8. Yeah.
And you can find width as equals to 4, correct?
4.
So
Okay,
that is
perfect. Yeah.
how you could do it. Perfect. Now, in
Got
addition
it.
to this, we could have, domain and range for L. So you
Yeah.
can say what could be the domain range, provided we do not give them many other conditions, right? So
Yeah.
sometimes you could have that also as a parameter. Is it okay? So I
Yes, sir.
think this is absolutely clear to you.
Yes, sir. Absolutely clear.
Any other question?
Yes, sir. So I solved all of these, right?
Mhm.
Everything else is pretty okay.
Yeah.
Like the table below consists of all ordered pairs. That was pretty okay too. It's just that question that I had confirmation on. So I think we can move on to exploring absolute value. Just touch upon it, and then we'll go to parent functions.
Okay, absolute value function. Okay. Now, actually,
Yeah,
let me tell you one thing. This absolute value function is a two-page chapter in your
two page,
particular
right?
curriculum. But this is one of the most important question and least
Yeah,
understood. So that is why I think you have to really focus on this particular chapter. Absolute
sir.
value means always positive, okay?
Yes, sir.
So application, look from the application point of view. When we say that the error could be like 1% plus or minus, you understand?
Yeah,
That means the value of 99 is also acceptable and 101 is also acceptable
Yes, sir.
if you're talking about 100. So 1%
Yeah.
plus and minus. So this is what absolute value is. You could also interpret absolute value as distance. You know, distance is always positive.
Yes, sir.
So think like this. Like if you want to say that I want to stay within 5 kilometers of my school area, in that case, it could be 5 kilometers north, 5 kilometers south, or east or west,
Yeah,
right? Within
absolutely.
that
Yeah.
interval. So that is the beauty of absolute function. It gives you kind of an interval
Yes,
within
sir.
that interval. Or if you say beyond, then also it gives you excluding this what. You get the idea.
Yeah.
So
So
that
it's
is
it's
how,
based upon greater than or equal to sign, right, sir? If it's
yes.
equal to, then it's filled in.
Yeah. So let me now tell you what absolute function is before we get into the details. So let me sketch this.
Yeah.
We'll sketch absolute function from straight line. Let us say that we have a line y equals to x.
Yeah.
So if I have to draw an absolute function, which is with these two bars on the sides, then it is always positive, right? So what
Positive,
really
yes.
happens is the negative part gets reflected, and what
Reflected.
you get is this function. So this becomes absolute value function. Is that clear to you?
Yes, sir.
So in fact, what you see here is that the absolute value of x is basically equal to x if the value of x is greater than or equal to 0. It was same, right? It overlaps.
Yeah.
But
Yeah.
it is minus of x when x is less than 0 because it got reflected here. Do you see that part?
Yes.
So basically, absolute function is also piecewise function.
Yes.
This combination of these two pieces, where it is decreasing from minus infinity to 0 and
To
then
0.
increasing from 0 to infinity.
Infinity.
And it has a vertex here at the origin itself.
Yes.
One more important thing is that this is an even function. Let me write down here, even function.
Yes, sir.
Even means that f of minus x is equal to f of x. There is a line of symmetry. So y-axis is line of symmetry.
Okay, so sir, a symmetric function is one that has equal parts of when cut through the y-axis. Am I right?
Yes, yes. So what I'm trying to say here is that if I have a point here, there will be mirror image point on the other side. So that those two distances are absolutely equal. Is that clear?
Yes.
Correct. So let's go through the exercise and do some questions based on absolute function.
Yes, sir. I had one question in particular because we touched upon absolute value before.
Okay, okay.
Sir, so if they give you a number line like this, or if they give you like absolute value of x is less than 8 or something like that, how would we approach these two problems?
Okay, so let's look into question number 4 first. So where we say absolute value is greater than or equal to 16, for example. Okay, so let me just sketch a line here. So I'll sketch a line like this. And on this line, let's do this first. X less than 8. So let us say we have a 0 here, right? And I want to sketch less than 8. So somewhere here we have 8. I will put an open circle and then left, where this point is 8. So open circle is not included.
Okay.
You get the way. So we have x less than 8 here, right? But the function is absolute value of x is less than 8. Do you see that?
Yes, sir.
So we have to take care of negative part also. So we have to look for the negative 8. Let us say this is negative 8, correct? So we have an open circle here. So everything in between is absolute value of x, which is less than 8. You understand now? So there is symmetry. There is symmetry, right? So we find that this has to be equal to that. So you could interpret with linear function also in this particular fashion. But it really means when we say x is less than 8, it means within.
Because it's an absolute function. That's why it's within, right?
Within plus minus 8. You get the idea, right?
Yes, sir.
Not including 8. Not including. Let me write down. Not including.
Because there's no equal sign, right, sir?
Yes. So that is how you're going to do it. On the other hand, if I have greater than or equal to, in that case, it should be like this. Let's say this is the number line. So if I have 16 here, then this 16 is filled in. Do you see that? Because
Yes,
it is greater than equal to. And greater than equal to means the other side like this. You understand?
yes, sir.
And symmetrically, we have minus 16 here. And the other way.
So then, yeah.
Do you see how the mirror image concept works?
Perfect.
With it? Correct?
Sir.
So that is what is the meaning of not including, but beyond. So this is means beyond. Okay.
Sir, with that same concept in mind, sir, if we take a look at 5C, right? Would the answer be absolute value of x is greater than or equal to 2?
Correct.
Okay, perfect.
But there is a difficult question to do, which I'll give you, which normally comes in test paper. Okay. So I will make a number line which is not symmetrical. So examples given in the book normally are with symmetry.
Symmetrical.
So let me just give you an example here. I'm including this point and I'm saying up to this point, and the values are for me, let me write down some values here. Okay, let's say this value is, let's say minus 4, and here we have 0.
Okay.
And this value here is plus 12. Now, how will you write this as an inequality with absolute function?
Right.
How will you do that?
Okay, sir. So first of all, it's not symmetric, right? So we can directly say that absolute value of x is greater than or equal to some value.
Yes.
So I think you'd see the distance from one point to the origin and then the other point to the origin, right? And then based off of that, you would form your absolute value notation.
No, not 1 point from origin. What we should do is step number 1, find midpoint.
Okay, so minus 4 plus 12 divided by 2, right?
So minus 4 plus 12 divided by 2 gives you 8 divided by 2, which is 4. So we found a midpoint, which is, let me write down here as 4. Do you see that?
Yes.
So that becomes the midpoint. And now from the midpoint, you find the distance to each side. So this distance from here to here is what? And from here to here is what? So you see both distances are 8. Now you see the symmetry. But this symmetry happens when you move towards the right by 4 units. Do you see that?
Yes, sir.
Apply the concepts of transformations.
Okay, so it's basically like a translation to the right, sir?
Yes. So it'd be absolute value of x. Since you move 4 units to the right, it is minus 4, and the distance remains within 8, both included. You get the inequality. Do you see that?
Wow. Okay. Excellent. Yes, I see that, sir. So you would basically include the transformation with the absolute value notation, and then this one would be less than or equal to because we're moving to the right, right?
Within
the distance, which is 8.
Yes, you get the idea. So that is how you're going to solve these kinds of equations. You can actually take a picture of this because that is very important.
Sir, one more question before I take a picture.
Yeah.
Sir, how would the number line look if it was absolute value of x minus 4 greater than or equal to 8?
Away. So away will be like this.
Away from minus 4 and 1. Okay, perfect. Yeah.
Like away.
Okay.
So that will be absolute value x minus 4 greater than or equal to 8. Oh, done, right?
Yes, sir. Perfect.
Okay.
Those were my doubts for this chapter.
Very good. So I think that's good. We can move on to the next chapter.
Yes, sir. I think, this is properties of graphs of functions, sir.
Okay, so move further. We'll see the parent graphs here. Because basically you're talking about these 7, I think. 7 parent.
Yes, sir.
Correct. So let's look into their diagram. Plus, you can also watch my videos on this particular topic when we are talking about the characteristics of parent functions. So in my videos, what I've done is I made a table so that you know each and every characteristics to deal with. You get the idea, right?
Yes, sir.
And then you could actually easily write down those parameters. So what I will do here is that if you move your page further, go to the exercise, almost at the end, they've made a table. Can you go through this?
Yes, sir.
Last question. Yeah. Look here. This last question has a table. Yeah, question number 12. So wait here. So what you should do actually is These are all the functions. Do you see f of x, straight line, linear function, quadratic function, reciprocal function, absolute value function, radical, square root function, exponential function, and sine function, correct? So in this chapter, basically, we are dealing with these 7 functions, right?
Yeah.
So you could sketch their graphs here and then write down the characteristics. For example, that's a straight line, that's the parabola. This is like 1 over x kind of a thing, right? So I'm just drawing roughly here, right? Kind of like this, and this is kind of like this. Is that okay? So you should do this job neatly. So sketch all the functions and then write down their domain. So as far as the domain is concerned, the domain of 1 over x has a restriction that x is not equal to 0, right? As far as other questions, this is x is greater than equal to 0, right? The others have all real numbers, right? So let me just write x belongs to real numbers. Is it okay?
Yes.
Now, as far as the range is concerned of all these parameters, this is y belonging to greater than equal to 0, right?
Yeah.
Square. And here, y is not equal to 0, but all other real numbers. Absolute function, y is similar to the quadratic function in this regard. Square root x is again y greater than equal to 0. For this, y is greater than 0. Do you see? Because
it's never equal to 0.
It has a horizontal asymptote. And for sine, we have the value from -1 to 1. I could also write it in this interval notation. Now, interval notation is very important to understand. It gives you that square brackets means included.
Yes, sir.
But if it is not included, for example, I could say from here minus infinity to plus infinity. You see that? So those brackets are not included. You get the idea?
Yeah. Yes, sir.
So you could use those brackets. So intervals of increasing, that's the next you can now see and define it. Now, as far as the intervals of increasing is concerned, I think one of the most interesting is 1 over x. Now, can you tell me what is the interval of increasing for 1 over x?
Yes, sir. I think the interval of increasing would be from 0 to infinity.
No. It never increases, none.
Oh, okay.
See, 1 over x, if you see, it is decreasing, right? From 0 to negative infinity. And then from infinitely large to this. So the
I thought it would go the other way.
Decreasing is there, but never increasing. Now, can you tell me what is the interval of decreasing for this particular function?
For 1 over x, sir?
Yes.
It would be always, right, sir?
No, not when x is 0. Do you see that? Always in its domain. So it is when x is less than 0 and when x is greater than 0. Do you understand?
But never add 0, right, sir?
So it is a very tricky question. So here, pay attention. Is it okay?
Sir, I think I'll fill out this table after watching this video.
And then you can ask me your doubts. Is that clear to you?
Yes, sir. Sounds great.
Yeah. So we have quickly done all this. Any other doubts?
Yes, sir. Can we touch upon discontinuities and asymptotes? Discontinuities in general. Like, I think I need to grasp the concept.
Okay, so I will actually share some other, you can stop sharing.
Okay.
On the whiteboard, I'll explain you. Is it okay?
Okay, sir.
Okay, so on a whiteboard, I'll explain you what is vertical asymptote and what is horizontal asymptote, right?
Yes, sir.
So we'll take 1 over x, which is your main function. Let me use a blue ink for the graph. That'll be better. So I'm sketching 1 over x, and then I'll explain you the concept of horizontal and vertical asymptote. Is it okay?
Yes, sir.
So let's look into what happens when x is approaching negative infinity. That is, you see when it goes on this side, what is happening? The y value actually approaches 0, but it approaches from negative side, so we write 0 minus. It is from the negative side, from below. Do you understand?
Yes.
From below. So, but 0 is a real number. And therefore, we say that the horizontal asymptote is y equals to 0.
Yes, sir.
So basically, horizontal asymptote is defined as when x approaches the independent variable, x approaches very large value, whether it is positive or negative, right?
Yeah.
Then if y approaches a real number, in that case, horizontal asymptote exists.
Yeah.
Is that clear to you? So that is horizontal asymptote. Now let's look into vertical asymptote. What happens when x approaches 0? So when you approach 0 from the negative side, from the left side, reciprocal of negative number is negative.
Yeah.
So we find that y approaches infinitely large but a negative value. Is that clear to you?
Yes.
So we say that we have a vertical asymptote at x equals to 0, right?
Yes.
You will also notice when x approaches 0 from the right-hand side, that is from this side, y approaches positive infinity. So from both the sides, when you're approaching 0, the function approaches a very large value. Do you see that? And
Yes.
therefore, there exists a vertical asymptote at x equals to 0. So x equals to 0 becomes your vertical asymptote. Is that clear?
Yes, sir. And y equals to 0 is your horizontal.
Yeah. So I'll prefer to draw horizontal asymptotes like this along the x-axis. And we can write this as y equals to 0 as horizontal asymptote. And that is my vertical asymptote. Is that clear to you?
Yes, sir.
So that is how you define horizontal and vertical asymptotes. So different kinds of functions will have different horizontal and vertical asymptotes. Is that clear to you?
Yes, sir.
Let me sketch a graph and then ask you a question. Very important graph. So let us say we have a function which is go through this, right? So let's say the function is kind of like this.
Okay, yeah.
This line is y equals to, let us say 1, right? And this is like x equals to, let us say -1. Can you tell me the equation of horizontal asymptote?
Yes, sir. The equation, so the horizontal asymptote would be y equals to 1, right, sir?
Why is it so? Tell me.
Sir, I think that it would be so because you see the green side that you do, right, sir? When
So when x approaches positive infinity, then y approaches
0.
1 from above. Do you see that?
Oh, sir. Oh, yes, sorry. Y approaches 1, not 0, because you're horizontal.
From above, right? So it is a real value that there is a possibility that the graph may cross horizontal asymptote. So remember that the graph may cross, not always, horizontal asymptote. Is that clear to you? So this is very important to understand. So at this stage, we'll just stop the class today. I hope we are gone.
Yes, sir. We covered a lot. Yeah.
Right. Can you please summarize what did you learn today?
Yes, sir. So today, I came just to learn the characteristics of the parent functions and just to clarify that one doubt. But it turned into like a basket of learning. Like we pretty much learned everything that I'm going to learn this entire week. So I found that really interesting.
Thanks. Good. And all the best. I'm expecting 100% marks from you this year.
Yes, sir. Hopefully.
As you did last year also. Perfect.
Yes, sir.
Great job, man. Thank you.
Bye. Thank you, sir.